Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0113, indicates a high voltage issue in the intake air temperature IAT sensor circuit. The IAT sensor is a crucial component that measures the temperature of the intake air entering the engine. It is typically located near the mass airflow (MAF) sensor within the intake duct. The information from the IAT sensor is essential for determining the engine's fuel and air mixture, directly influencing engine performance and emissions. When a high voltage reading is detected, it may signify a fault in the IAT sensor itself, or indeed in the associated wiring and connections. Prior to retracing the fault, it's vital to verify the problem, which helps in ensuring efficient troubleshooting. The error code P0113 specifically indicates a high voltage scenario within the IAT sensor circuit. The IAT sensor plays a pivotal role by relaying vital information about the temperature of the air being introduced into the combustion chamber. This sensor is generally integrated into or placed close to the MAF sensor to ensure accurate readings that are critical for optimal engine management. A faulty IAT can provide either erratic or consistently high or low readings, which can trigger this DTC. This may lead to poor engine performance, such as stalling issues or increased fuel consumption. It's also crucial to highlight that the issue might stem from poor connections or faulty wiring between the IAT sensor and the powertrain control module, PCM. There are several possible causes for the DTC P0113. The primary reason is a failure in the IAT sensor itself, which can occur due to internal short circuits or external damage. Wiring issues, such as breaks or shorts in the harness, can also lead to incorrect voltage readings from the sensor. Additionally, loose or corroded connections at the IAT sensor, MAF sensor, or the PCM can be a significant contributor towards triggering this code. Before implementing repairs, it's paramount to visually inspect all related wiring and connections to determine if any obvious faults exist. Sometimes a fault may not be apparent until further diagnostic testing is performed, using appropriate tools like the Honda Diagnostic System, HDS. Vehicles exhibiting the P0113 code may showcase several symptoms that indicate an underlying problem. The most common symptom is the illumination of the check engine light, CEL, on the dashboard, which alerts the driver to a potential fault. Moreover, the incorrect readings from the IAT sensor can lead to an improper fuel-air mixture, ultimately causing poor engine performance, such as reduced acceleration, stalling, or difficulty starting. Affected vehicles may experience abnormal fuel consumption patterns, either too rich or too lean conditions, affecting overall efficiency. Additionally, drivers may notice strange engine behavior during hot weather conditions when the IAT sensor is most likely to experience stress. The first step in troubleshooting the DTC P0113 is to confirm the problem's existence. Start by turning the ignition switch to the on position or selecting the on mode via the engine start-stop button. Utilize the Honda Diagnostic System, HDS, to systematically check the IAT sensor data. Here you want to observe if the IAT sensor indicates a reading of approximately -40 degrees Fahrenheit, -40 degrees Celsius or below, or if it displays a voltage of 4.92 volts or higher. If either of these conditions is met, it confirms that the failure could be duplicated, prompting you to proceed to troubleshooting step 2. Otherwise, you might face an intermittent failure, indicating that the system might operate correctly under certain conditions. It is advisable to check the connections and wiring related to the IAT and MAF sensors, as they may reveal loose terminals or corrosion affecting electrical signals. In this second step of troubleshooting, The focus is on determining the possible failure area. Begin by turning the ignition switch to the lock position, or turning off the engine using the start-stop button. Once ensured that the vehicle is off, disconnect the MAF IAT sensor 5P connector. Afterward, proceed to use a jumper wire to connect terminals A and B. Terminal A corresponds to the MAF IAT sensor 5P connector number 4, which is typically denoted by a red-yellow wire, and terminal B corresponds to number 5, generally the green-yellow wire. After making the jumper connection, switch the ignition back to the on position, and once again check the IAT sensor data with the HDS. If the sensor indicates a voltage reading of 4.92 volts or higher, or a temperature of -40 degrees Fahrenheit or less, it suggests that the fault potentially lies not within the sensor, but possibly downstream. Upon concluding Step 2 successfully, Step 3 continues to scrutinize the wiring associated with the IAT sensor. Start this troubleshooting step by turning off the ignition switch, then carefully disconnect the jumper wire you used previously. After everything is in place, turn the ignition back to the on position. With the jumper wire removed, you will need to measure the voltage between designated test points. Test point 1 is located at the MAF IAT sensor 5P connector number 4, which corresponds to the red-yellow wire, while test point 2 is a body ground. Ensure you are leveraging appropriate voltage measuring equipment to obtain an accurate readout. If the voltage indicates approximately 5.0 volts, it indicates a healthy circuit, which affords you the option to move on to Step 4, focusing on the SG2 line for more specific troubleshooting. As you progress to Step 4, your focus shifts to the SG2 line. Begin by turning the ignition switch to the lock position or off. Next, utilize the Honda Diagnostic System HDS to jump the SCS line. Disconnect the PCM connector B51P and inspect for continuity between the designated test points. Test point 1 is found on the PCM connector B51P number 5, marked with a green-yellow wire, while test point 2 corresponds with the MAF IAT sensor 5P connector number 5, also marked with a green-yellow wire. Assess whether there is continuity present between these locations. If continuity is confirmed, you can rest assured the SG2 wire is functioning correctly. At this stage, it is recommended to check for any software updates for the PCM. If applicable, update or substitute the PCM and check if DTC P0113 clears. If it does, you have completed troubleshooting successfully. In the final troubleshooting step, you are tasked with examining the TA line. As previously mentioned, initiate by shutting off the ignition switch to the lock position. Similarly to previous steps, jump the SCS line using the HDS tool. Following that, disconnect the PCM connector B51P and navigate to inspect continuity between your designated test points. Test point 1 pertains to the PCM connector B51P number 30, indicated by a red-yellow wire. Test point 2 should be the MAF IAT sensor 5P connector number 4, also indicated by a red-yellow wire. After performing a continuity check, if continuity is confirmed, the TA wire is functioning appropriately as well. Again, check for any updates for the PCM software to ensure it's at the latest version. If the DTC resolves after updating or replacing the PCM, you have successfully completed your troubleshooting process. After completing all necessary repairs related to DTC P0113, the next crucial step is to verify success. Begin this verification process by clearing all diagnostic trouble codes using the Honda Diagnostic System HDS. Once the codes are cleared, it's essential to perform a thorough road test to ensure that all systems function correctly without recurring symptoms. Keep an eye on the dashboard to confirm that the check engine light, CEL, does not illuminate again. During the road test, monitor the engine's performance for any signs of irregular behavior, such as misfiring, stalling, or hesitation. Successful verification means that no DTCs return and the vehicle performs optimally, confirming that the initial issue has been resolved satisfactorily. To prevent the occurrence of DTC P0113 in the future, regular maintenance is key. It is advisable to routinely check the connections associated with both the IAT and MAF sensors for signs of wear or corrosion. Inspecting these components during routine vehicle maintenance can help catch issues before they lead to more significant problems. Additionally, it's essential to ensure that all control modules, especially the Powertrain Control Module, PCM, are functioning correctly. Have updated software. Manufacturers often release updates that improve performance and eliminate bugs associated with earlier versions. Keeping your vehicle maintained not only minimizes the risk of related DTC errors, but can also help enhance overall engine efficiency. In summary, DTC P0113 signals a high voltage condition affecting the IAT sensor, critically impacting the vehicle's performance, fuel efficiency, and emissions. Recognizing that the IAT sensor plays a vital role in the engine management system emphasizes the importance of a systematic approach to troubleshooting this issue. By meticulously following the structured troubleshooting steps, technicians can pinpoint the issue, whether it's the sensor itself, wiring problems, or PCM-related failures. Finally, maintaining a proactive attitude towards inspection and preventive maintenance is crucial in minimizing future occurrences of related DTCs and ensuring the ongoing reliability of the vehicle. Please like and subscribe to the channel. See you next time.